Okay, so we're going to skip over the first couple things. We're going to turn to page 273. Take out your highlighter. You're going to see some of the same things that we did in 4.1. Here we have adding functions, okay? The different notations that you either see them adding like that or adding like that. And then the textbook just goes through here and says, add them up. Now, since the domain of the red graph started at -2, when you're adding your functions, your new graph will start at -2 as well. So we've seen that already. Subtracting. Notation either like that or like that. Oops. And again, since the red graph only starts at -2, same thing when you subtract. You can only subtract things when they exist, and so your green graph starts at -2 as well. Multiplying, notation like this, notation like that. And they leave the dividing for a little bit later because of the asymptotes. Again, you just take your y values and multiply them. Some of the ones that are easy when multiplying, okay, again, things are easy wherever the red or the blue graph is equal to 0, because multiplying by 0 doesn't change anything. Things are also easy whenever the red graph or the blue graph is equal to 1, because when you multiply by 1, you notice that the green graph is exactly the same place where the other function is, because multiplying by 1 won't change that value. You can also see where both the red and the blue graph are positive, the green graph is positive. But if one of the functions is positive and the other one is negative, so anywhere past here, the blue one is negative, the red one is positive, your green graph is going to be negative, because a negative times a positive is negative. All right, example number 1. So it's going to be a good review of transformations, because you're going to have a lot of your parent graphs from transformations that you're going to do a quick sketch of. We're going to find explicit equations from it, and then work at figuring out what these graphs look like. So here is an axis, x plus 2. Pretty straightforward one. I'm going to make that graph blue. So if you have different colors in this unit, it's really helpful, because you can color code things. X plus 2 would have a y-intercept of 2 and a slope of 1. Be a perfectly straight line, just like that one. And there's my blue graph. In red, I'm going to draw the absolute value of x. Do you remember what the absolute value of x looks like? Like a V. So it's like y equals x on this side, and like y equals -x on that side. I do have a color pen. Oh, those ones are done. You can check in here. Here's a red. Okay. So for the blue one, can you see that the domain is everything and the range is everything? And for our original red graph, that our domain is everything and our range is only when y is bigger than or equal to 0. Sometimes drawing the original graphs helps you see the domain and range easily. For part B, we've got a function which says add them. Now when they ask for an explicit equation, what they want you to do is write h of x equals, and then on the other side only use x's, not use other functions. So if it's f of x, and f of x was the blue one, instead of f of x I can write x plus 2. And instead of g of x I can write absolute value of x. Here, it might be this one.
No, it was music.
Okay.
I don't think you need that.
No, I'm good. Thanks. So that's going to be the explicit equation. Now we have to determine the domain and range of this one. Now if we're adding functions, let's look what happens to these two graphs when we add them. Okay, so we're going to go through some points. Here at 0 and 2, adding those two together will be that. Here I'm going to have 1 plus 3 will give me 4. Here I have 1 plus 1, which will give me 2. And here I'm going to have 0 plus 2 is going to give me, oh, sorry. Is this 1 and 1 is 2? 0 and 2. Yeah, there's 2 spots of 2. If we keep going, we're going to notice something. If I would go one more point here, I'm going to have negative 1. And here I'm going to have 3. And what happens when you add negative 1 and 3? You get 2 again. So we start seeing a pattern here. Here it's going to be straight, because all of these ones and all of the red are going to cancel out and always be 2. And then after this, it's going to go up like that. Weird looking graph.
Wait, what was that for?
This point here, this is 1 and this was 3, so yeah, it'll be right at 1 comma 4. So now for our final green graph, the domain is still everything. The range is going to be y is bigger than or equal to 2. The smallest it ever gets is 2. And one of the things that you're going to find in this section is you're going to have with graphs like h of x. Have we ever graphed x plus 2 plus the absolute value of x before? No. For the most part, they're either going to be graphs like this one, where you have a lot of nice points that you could figure out point by point quite a bit what the graph is going to look like, and then figure out the domain and range. And if they have a lot of not nice points, they're going to let you use your calculator. And if you can use your calculator, you're going to type this into y1, graph it on your graphing calculator. You're going to be able to find minimums and maximums if you need to use that for your domain and range, and work from there. And that's exactly what we're going to find in part C. So for C, we're going to write a new function p of x. It's equal to f of x, which was x plus 2, multiplied by g of x, which is the absolute value of x. And we're going to use our calculator now to see what that graph looks like to figure out the domain and range. So you go to your y equals you've got x plus 2 multiplied by, now the absolute value can be found under math. Go over to number. Mine shows up as ABS. If you have a newer calculator, it might actually give you the straight lines. Absolute value of x. And we're going to see what this looks like. Woo! Fancy. Now looking at that, can you see that it goes up forever and down forever? Can you see it goes to the left forever and to the right forever? So our domain and range will both be everything. Not so easy just to take those graphs. If we were multiplying values, we'd be like taking a lot of time to do a lot of points. And so here is an example of where the graphing calculator is a lot nicer than doing it by hand, because you get the answer right away. So if you have these questions on a calculator part, take advantage of your calculator and graph it. If you do that on your exam, make sure that you explain that I've used my graphing calculator. This is what my graphing calculator screen showed. From that, I was able to determine that the domain and range was everything. Okay? Because if you just write the answer without an explanation, they're not going to give you full marks for that. Okay, here's an example 1. Now, go back to our notes. We got some more highlighting to do. Quotient of two functions, again, the two notations. Also, notation that looks like this. This is right after example 1, right at the top of page 275. And we can just highlight the fact that now where you have the function that you're dividing by, if it's ever equal to 0, you may have an asymptote or a hole.